In previous example, we used one value and we did a sensitivity analysis to find out at which range we're going to select the alternatives. This time we're going to try to address all values because we are not sure what's going to be the value in the future. So what I'm going to do here, I'm going to start with the example 18.2 here. In this example, we have an alternative as initial cost, net income, salvage value, and the life, but we are not sure about the values. So what we're going to do, we're going to provide some value, we call this an optimistic value, most likely value, and also pessimistic value. So the initial cost is going to be optimistic value $950. Most likely value is 1,000. Pessimistic value is 1,150 because we are not certain what's going to be the initial cost. Now, the net income, also we're going to have three values. This is going to be $210 per year, 170 here. Now the next thing is salvage value. For the first optimistic value 100, we're going to assume 0 for most likely and 0 for pessimistic value. Same thing with the life. So we're going to have 12 years, 10 years, and 8 years. So obviously for each information we have three values, optimistic, most likely, and pessimistic value. So what I'm going to do here is I'm going to show you what's going to be rate of return if I'm using the optimistic value or most likely or pessimistic value. I'm going to do only for optimistic, then I'm going to provide the rate of return for each other alternate situation. So let's find for optimistic value. I use O for optimistic. So the cash flow diagram is going to be like this. $950 initial cost. You have net income. For this one, let's go for 12 years. So it's going to be $210. And the salvage value, 100. So if I try to find the rate of return, we have done this on the previous chapter. So present worth of revenue minus present worth of cost equals 0. So the revenue is 210, P given A, I is unknown, and 12 period. Then we have the salvage value 100, P given F, I %, and 12 period, minus the initial cost, 950. Now, if I set this equation and solve for I here, again, I'm not going to do it because we have done it in previous chapters many times. So I'm going to find the rate of return for optimistic value is going to be equal to 19.8%. Now, these values are most optimistic. You have lowest income, higher income, and higher salvage value and higher life here. So obviously, I get higher rate of return here. We're going to continue with the example 18.2 here. Now, I found out the rate of return for optimistic was 19.8%. Now what I'm going to do, I'm trying to find the rate of return for most likely. So for the most likely, the equation is going to be the present worth of revenue minus present worth of cost equals 0. So we have, there's no salvage value here. So it's going to be 200. So it's going to be 200 times P given A. I and the life this time is going to be 10 years. That's most likely. minus the initial cost, which is going to be 1,000, equal to 0. If I solve this equation, the rate of return for most likely is going to be 15.1%, which is much smaller than the rate of return for optimistic value. Now I'm going to do this one for more pessimistic value. So the same equation, present worth of revenue minus present of cost equals 0. My costs, my revenue is going to be less this time. Is going to be 170 P given A. The life is 8 years for pessimistic value. Minus the initial cost, which is 1,150, equal to 0. If I solve for this, the rate of return for pessimistic value is going to be much less than previous cases. So it's going to be 3.9%. As you can see here, there's a big range between the rate of return, is starting from 3.9% to up to 19.8%. So obviously it's not clear which one is the actual rate of return here. So how are we going to resolve this? So I'm going to discuss this one using a method. We call this one mean value. So what does it mean by mean value? What we're going to do here is we're going to find a weighted average. Normally we're going to assign a weight of 1 for optimistic value and weight of 4 for most likely and weight of 1 for pessimistic value. Since we have 1, 4, 5, 6, we're going to divide this one over 6. So basically for every value, we're going to find a mean value. For example, for first cost. So this is the mean value for first cost. So what we're going to do here is, for first cost, if you recall, the optimistic value was 950. Then the most likely value was 1,000. And the pessimistic value was 1,150 here. If I divide this by 6, I get a new value, which is going to be $1,016.70. So that's going to be the mean value for the first cost. So I'm going to do the same thing for other information, like the next one is the mean value for income. So it's going to be 1 time 210 plus 4 times 200 plus 1 time 170. Divide by 6, I'm going to get net income of $196.70. So next thing, we're going to find the mean value for a life. So we have the optimistic value was 12. Most likely value was 10 years. And pessimistic value was 8 years. If I divide this one over 6, I will get 10 years. And the last thing we're going to do for the salvage value. So this is the mean value for the salvage value. This one, we're going to have, actually the only optimistic value was 100. So 1 times 100. And the pessimistic value was 0. And also the most likely. If I divide over 6, I get $16.70. So once we have all the information regarding the initial cost, net income, the life, and the salvage value based on the mean value, now we're going to find the rate of return here. All right, we're going to continue with example 18.2. So we find the mean value for initial cost, net income, life, and salvage value. Now we are trying to find the rate of return based on mean value. So what we're going to do is we're going to set present worth of revenue minus present of cost equals 0. So the revenue, it was 100, the mean value, $196.70. We're going to multiply this one by P given A, I, and the life based on the average was 10 years. Now, the salvage value was $16.70. We're going to multiply this one by P given F, I, and 10 period. And this, the initial cost was $1,016.70. If you set this one equal to 0 and solve for I, that's going to be the rate of return for based on mean value. It's going to be close to 14.3%. Now, I'm going to repeat the information we got earlier. So the rate of return based on optimistic value was 19.8%. The rate of return based on most likely value was 15.1%. And the rate of return based on pessimistic value was like 3.9%. If you look at this, the rate of return based on mean value is very close to most likely. So actually, it's a good idea to use this one because you're not overestimating your rate of return or you're not underestimating. So that's why the most likely is very close to the value you're going to get based on mean value. And most people use that information to make a decision rather than using the optimistic value or pessimistic value.